Wow, Mrs. Kumar, wow, the sun's so tough, so long. Ayo, so frightening. My God, ayo. What? That's not very difficult. Can't do it. Like that. Oh, Cobra! Ah. Hey, class. Hey, my dear. Don't put on your dark glasses and say, the sun is so tough, my dear. Come on. Alright? Don't be afraid of the cobra. It's an adorable creature. Learn to take it. And if you have any fear, catch it by the neck and put it into a gunny sack. Tie it and just get it out. So when you put a mask over you, my dear, you feel the fear of the sun. Unveil that fear and smile and say, cumulative frequency is great. I can do it. So can you. Just tell yourself and tell your friend, come on, Arvind, we can do it. I'll say, really? Yeah lah. Okay, we'll do it. So, my dear, let's do it together. Cumulative frequency. The more information you see, the better it will be because it clarifies. It makes it so interesting. What happened? The actual arrival time for fast track train at Butterfly Garden Station is 7:30 a.m. each day. Unfortunately, the arrival time fluctuated to frustration of office goers, and a complaint was made by the office goers. And what happened? So the kind officers, they studied the arrival time. All right, they recorded it over a period of 100 days, and as shown in the table, they've got all this. And what do? This is everyday maths, real life. When you got a complaint, this is what they do. How many days you're late, and then they take action. So let's find out what is the mean time that a train comes. When it's supposed to arrive at 7:30. Look at it, there's some trains till 7:36 on 7 days. Wow! And even imagine you go at 7:30, 7:29, and then you miss the train because till 26 minutes, from 7:24 to 7:26, 4 days trains come early out of the 100 days. And we go at 7:29, you still see it another 14 days. The survey shows from 26 minutes to 28 minutes, 7:26 to 7:28, 14 days. And then from 28 to 7:30, if you're just on time, imagine you say, wow, 7:30. But you need time to move up the escalator to get the train. Will you catch it? Look at the number of days if you add them up to 7:30. Wow, 18 plus 20 is 38 days, 38%. 38 out of 100, you will not catch the train. So, my dear, be careful. And there are days, you look at that, you're going to be late. So this is what we call a table charted to study. And they want you to present this in a frequency table, and you want to draw the frequency graph to illustrate the given information. And they also say, Miss Valerie Leong, a company secretary, reached the station at 7:20. And they ask you to calculate the mean estimated time she should wait. Wow, it's not really difficult. Look at it and say, is it tough? No. Let's smile together. Your sweetest smile, my dear. I see it in your eyes. Okay, you're worried about Valerie Leong. My dear, she's an old lady, 56 years old. All right? So, let's find out what's Valerie Leong's waiting time. Are you with me? Great. So, she says she came at 7:20. What is the estimated waiting time? Now, let's look at here. The time between, there's a range you're given. And from 24 to 26. I'm not interested in 07, my dear. I'm looking at this range. So you want to find at what time, average, the average time from this 100 days. What is that average time that the train will arrive? If you're going to tell me between 24 to 26 is 2 minutes range, and you're going to put a 1 times 4, I'm afraid no. And then you say, hey, it's a 2 minutes range. You take a 1, a middle distance, times 14. No, you're on the wrong track, my dear. So how do you do this sum? Can I hear you? Say it loud. All right, it is 7:25, the mean time. So we look at the mean time. A, we're going to do this sum. All right, be with me. 25, 7:25, all right, times 4, plus 7, 26 to 28. The middle is 27, times 14, plus 28 to 30 is 929, times 20, 29 times 20, plus, you look at this, 30 to 32 is 31, times 30 days, all right, 31 times 30, and you look at this, 32 to 34, 33 times 25, yeah, and we move on, 33, 34 to 36 is 35 times a 7, so plus 35 times a 7. You get this total, the big bracket, divided by 100, and that will give you the mean time. So when you work it out, you put them all together, press it into your calculator, please, take it, and then you put in 25 times 4, all right, plus 27 times 14, and you work that all out, and you would get, and you divide it by 100, and what you get when you divide by 100, you will get a time of 10.58, the average, all right, 30.58, you would get that, 30.58. I hope you got it, all right, you look at it, 25 times 4, you get 100, plus 27 times 14, plus 29 times 20, all right, plus 31 times 30, plus 33 times 25, plus 35 times 7. All right, sum them all up, you get 3,058 divided by 100. When you divide by 100, you get this answer. All right, look at that. And it's a fraction. And you want to change it to decimal. You get 30.58. Now, that's about, that is an average time. The average time that the train will arrive is actually, average arrival time is 0730.58. So we said that is arrival time, average. Not too bad, all right? And she comes at 7:20. So her average mean waiting time, what will that be? You take away 7:20, you get average waiting time will be, you minus 0720 will give us 10.58 minutes. That's what she has to wait. Got it? So we look at the timing and we can say, not bad. The average time is about 7:30.6. You look at that. But that's just the mean arrival time. But Valerie's waiting time will be about 10.58 minutes. Have you all got that? Great. And you do see the mean arrival waiting time. This is the average, or shall I say, mean arrival waiting time. That would be better, don't you think so? All right, so we write here, mean arrival time. So that's the mean arrival time. Look at that. And then this is Valerie's waiting time. Valerie, if I were to put that, average mean waiting time. All right, so we should tell Valerie, hey, don't go so early lah. Huh? What do you think? Can go at 7:30? Maybe you can get it. All right, so I'm just saying this is what the sum is about. Okay, let's move on to the next part. They said, hey, complete the cumulative frequency table from 0724, before that, for this time, this train. No number of days. Now up to 726, you can see 4. Cumulative, my dear, up to 728, add them up, you get 18. 18 plus 20 here, you get 38. 38 plus 30, 68. 68 plus 25, 93. 93 plus 7, the 100 days. So you've got this in a cumulative frequency table that answers question 2. Now let's go to question 3. You have to draw the cumulative frequency graph to illustrate the given information. Imagine you are that officer. You have done the survey and you want to present it. And then from this graph, you are expected to find the mean time and the interquartile time. The mean time, my dear, we actually worked it out mathematically, arithmetically, right? But here, we're going to use the graph to get the mean time as well as the interquartile frequency, the interquartile range. So we're going to draw the graph, we're going to draw the cobra. Have no fear of cobras. Just do it confidently. Let me make some space, clear this part of it, and I'd like you, while I'm doing this cleaning up, can you get your graph done? Neaten up, or check it out, look at it, the part A and ask yourself what went wrong or what went right. If you got it right, give a pat on your shoulder. Hey, like that. Okay? Now like this duster, it looks good. Hey, but there's some parts of it that leaves a bit of stain. You know, when you do your work, you got to be neat. You got to make sure that these things are practiced. All right? So use your razor. Sometimes you just want to make sure that things look nice. And I'm quite fussy. I just want to make sure I've got a nice board for you. Good. Excellent. So neat presentation carries weight. If your writing is untidy, you also lose your marks. So please make sure you get that. All right. Now we've got to draw this graph, present this in a cumulative graph. And we look at the timing, 0724 to 0736. All right. And if they did not give you the scale, don't fear. The freedom is yours to determine what it should be. And we're going to draw it. So let's get that going. All right, timing. This is C. We need to draw the graph. And this is the score. The score is actually the timing. The frequency is the y-axis. All right, so we write it as the y-axis, the cumulative frequency. Please specify, remember. Otherwise, people don't know what this graph is all about. And the cumulative frequency is in terms of the number of days, right? Okay. And this axis is about time, the x-axis. And let's find out the time. You're starting off at 0724. 724. So let me be a bit 24, 26, 28, 30, 32, 34, 36. All right? So let me write it a bit neater here. 0724. So I'm going to just put it as 26, 28, 30, 32, 34, and this will be 0736. I hope you can find space to write in your work. Please do that. I want to teach you. I don't want my answers to be cramped, so it's a bit difficult. All right? Now, the number of days is 100 days it heats up. So your cumulative frequency is going to be 100 days. We got to scale it for 100. So let's look at this. 10, 20, 30, 40, will it be enough? 50, 60, 70, 80, 90. We go a little bit higher. All right? And we said 100. 100. Yeah. 100 is there. So record it. 10, 20, 30, 40, 50, 60, 70, 80, 90, and that's your 100. Please be neat in your graph, all right, when you draw them. Next, now we've got to plot it. For 724, it's 0, pop, across. 726, it's 4. So this is 10, half of it, and less than half, 726. And 728, it is 18, all right? So 728 is 18, go up, 18 somewhere here. And 730, if you look at it, is 38. You see a sharp increase, 38, somewhere around here, 38 is about there. And if you look at 730, 732 is 68. Woo! So 732 is 68, is almost, draw a vertical line. I'm not very happy with this. Okay, 768 is about there. So that's what you get. And for 34, it is 93. Yeah, 93. All right. And 93 is somewhere here. 93. Yeah. And if you look at 100, you get 76. Right. So, use a ruler, my dear friends. All right. I just want to make sure that concepts are taught to you. And that's my focus. In your case, your accuracy matters a lot. Now you join these crosses with a steady hand. Have no fear. Join them and see the shape of the cobra. All right? See the shape of the cobra rising beautifully. It's a steep rise, telling us that the interquartile range is very small, not too bad. But just that the office goers are a bit too fussy. Hey, they're a little too fussy about waiting. You know, this is what happens to you too. Don't you agree with me? Do you get up on time? So, let's look at this. And we've got this lovely graph done. And you can see the cobra and how it rises. From there, you're asked to find the median and the interquartile range. So where does the median? You have 100 days, and you look at the middle of 100 days, 50th percentile. So that's section C we've done. And in D, the median. The median is the 50th frequency, which is 50 days. Look at that, all right? And then you drop it down, and you look at that. So the median time arrival is about there. You can see 0731. This is 0731. Not too bad. From what we did in our arithmetic mean, we found out is 0730.58. Look at that. And our graph tells us 0731. All right, and this 58, if you do an approximation, it's about there. So this is doing mathematically, arithmetically, whereas this is doing our mean from a graphical representation. All right, take note. The interquartile range. What is the interquartile range? All right, you look at the 25 percentile. 25% of 100 days is 25 days. And you look and you read 25 days, what is your range? And you say, hey. So if you part 2, interquartile range is the upper quartile minus the lower quartile. And the upper quartile is the 75th percentile of 100 days. That is 75 days. And you look at that and you read, go downward, and you can see that the upper quartile is about 33. And the lower quartile, 25%, is about 29.5, it looks like. And so the interquartile range, my dear, is only 3.5. All right? So that tells us 3.5 minutes. So the range from the upper quartile, just give and take, 3.5 minutes. So it's not too bad. All right? Which is a very narrow. And you can see one look at the graph that it is a very steep rise. Unlike a very slow and a gradual. A slow and a gradual cobra shows there's a very big spread. So the interquartile range is very big. And I tell you frankly that fast track better close down. You better, I would tell that officers, please take a bus. All right? Whereas this is not too bad. Just that some little adjustments need to be made. Okay, we have done the lower quartile range. We've done so far right up to here. Now let's find out about Ronald. Arriving at the Butterfly Garden Station by cab, he takes him 3 minutes each day to get to the train, and that's due, the train that's due on 7:32, at 7:32 on a particular day. So what you are asked to find is the probability that he caught the train on that particular day at this time. All right? Probability means the chance. What is the chance that he got the train at 7:32? And you see, 3 minutes to take. So if he wants to take the train at 7:32, he needs 3 minutes to walk up, and you want to look at that chart. So what do? You take off 3 minutes from here. 7:32, it took him 3 minutes each day. So if you want to get the 7:32 train, you got to look at 7:29. All right, 7:29. How many days? So we look at this chart again, 7:29. Where are you? And then you find the probability. Yeah, this is the part, 7:29. And then read from here. And so 7:29, the earliest, right? So that's the earliest that you can be there to get. So if you look at the chance, how many days are there? If you look at it, they could be at 7:29. Okay? It must not. He must at least be there by 7:29. Otherwise, he cannot take the 7:32 train. So what we're trying to say is that although number of days that he can take, the 7:29, he has to be not after that. So there are 20, look at this, about 19 days. So the probability that he will be able to take the train is provided he reaches the station at 7:29, and that's how you can get the 7:32 train. And if it's 7:29, take the timing at 7:29, look at that, and I will look at that as the probability of arriving under 0729 is about 18 out of how many days? You can see 100 days. So that's the probability. 9, you divide 9 upon 50. 9 upon 50, what am I writing here? All right, so that's the chance that he could catch this train to arrive at 7:29. So not too good a chance. He should come in a bit earlier then. So you can see, my dear, the probability that Ron will be able to catch the train if he takes a cab to reach the 7:32 train. 7:32 train. All right, he wants to catch. All right, but he has to take this. It takes him 3 minutes to go up the escalator, walk to get the train. So he has to be there at 0729. So 0729, you look at it, 0729, read up, and 0729, where are you? It's here, and we look at it, it's, where did I get that? I got 18. This is what we got. All right, let's look at it. 29 is here. I took the middle point. Everybody look up. We draw this here. Hey, 0729. Get there, and we got about 18. 18. As long as it's before that time, he could get the 732 train. So it's 18 out of 100, which is a probability of 9 out of 50. All right, for him to catch the train. So, my dear, Arvind, now you understand? Yeah, teacher, very easy. Really? Easy lah. Oh, so you find it easy. All right, great. Do you find it easy? All right, no fear of the cobra. It's so easy to do the sum. Remember, the steeper the cobra is, when it rises its head right up there, it means the interquartile range is very low. All right, that means it's a shorter, it's very consistent. The deviation is less. So this is a pretty good sum in everyday example of cumulative frequency. What we did at first to find the mean time. To get the mean time, remember, you got to find the range. And you look at it, you take 725. You don't put 0725 times 4. You look at the data that we are playing around with. It's 24, 26. So you take 25. All right, 26, 28. So you take 27. So you look at that mean that we did. All right, we worked it out. And then we divide it by 100 days. And we've got this. And then you put in the 07 down. And you get 0730. 730.6. About there. The train, the average mean time of the arrival. Then you find Valerie's waiting time. Because she comes there earlier, 7:20, and that's the mean. So waiting time, you take away 7:20, you get 10:58. That's the amount of waiting time. Remember, this cumulative frequency plotting is pretty easy. Drawing the graph, no problem. Getting the mean and the interquartile range from the graph, that's something. Remember, the score is here, the frequency is there. Draw the graph, and you know one shape, yep. But if a graph is like that, hello, certainly wrong. So you got to find out what happened. All right? And if you want to look at Ron's waiting, if he comes, he wants to catch the 732 train, and it takes 3 minutes to do all that, to walk and get there, that means you got to check out the graph for 7:29, giving the 3 minutes for him to walk. So from there you read, that's about 18 days out of 100 days. He would be able to get that train. All right, my dear, have no fear. Go on to question 5, and we'll see how you move on together, all right?